1, 2, 3, test, test, test. 1, 2, 3. Can you hear me? Can you hear me? If you can hear me, go ahead and type yes in the comments. See, now this was before the morning show. Sometimes with our director Brad, I like to say something cheesy to make him groan. I'll say, paging Mr. Raffone, Mr. Mike Raffone, your table is ready. Mr. Mike Raffone. Ah, I see a bunch of yeses. So, microphone, your table is ready this morning. Hey, how's it going, everybody? Happy Monday. We got people already on here on Facebook. Let's see here. Who is on here this morning? Ron Keplin is watching. Brennan Leverton is on here. Good morning. Good morning to Nancy Jones. Yes, a very appropriate topic today, right? Let's see here. Jen and Ty Krenz in Pine River. We got Mike Dietzen in Appleton. Let's see here. Amanda and Corbin Zenker. Good morning to you guys as well. Debbie and Grayson Sager in Black Creek. Well, we've got, let's see here, Jennifer Fry in Two Rivers. Let's see here, Noah in Illinois. Good morning to you. And Tiffany Ellingson and Avery in Green Bay. Hello to you guys as well. We got a whole bunch of people on here. Gosh, my goodness. And hey, there's Callie and Megan Christensen. I remember meeting you guys at the TV station a while back. Well, thanks for stopping by here on Facebook Live. We've been covering a whole bunch of weather topics over the past several weeks, ever since school, had to switch to a stay-at-home situation because of the pandemic. But I'm trying my best to give you guys a little bit of atmospheric education, a little science education to get you by. If you missed it, some good news last week. These Facebook Lives have been transferred over to YouTube. If you go into YouTube and if you type in WBAY and Steve Beylon, I would assume that you probably would find them. There's, I would say, 6 different weather schools in there. We've been talking about hurricanes and thunderstorms and lightning and tornadoes, a whole bunch of fun stuff. And so you can go in there and watch the previous weather schools, and those will always live there and always live here on my Facebook page if you go to the video section. Today we're talking about types of precipitation. And intentionally, I wore this tie. Now, I call this my raindrop tie. You see that? Now, it's raining today, so that's part of the reason why I wore it. The other reason why is because we're talking about types of precipitation on weather school. But the funny thing is that, very often if we're drawing rain, we draw raindrops like this. But did you know that when rain falls out of the clouds, it is not shaped like teardrops or raindrops? No. Very often rain, when it falls out of the clouds, it's actually shaped more like kidney beans, bean-shaped. And if raindrops get big enough, they actually look almost like parachutes that fall out of the sky and splatter together. Sometimes those very large raindrops that are shaped like parachutes will actually tear apart into 2 smaller raindrops, which won't look like this shape, more likely to look like kidney bean shape. So I know that's kind of strange, to think of rain in a much different way. My job is to track precipitation. Do we all know what precipitation is? Precipitation, it's all part of what we call the water cycle. There's actually 3 major parts of the water cycle. There's evaporation, where water vapor comes out of the ground or out of bodies of water and floats up into the sky. When that moist air floats up and cools in the atmosphere, we form clouds. That's condensation. Condensation is also when I create fog on my glasses. That's condensation. And if those clouds get heavy and we have lots of raindrops or snowflakes and we can't hold on to that moisture, it falls back to Earth as precipitation. Now, my job is to track precipitation. I am say it all together here, in fact, it's on the bottom of the screen here. My job is a meteorologist. A meteorologist doesn't study meat. A meteorologist doesn't study meteors. A meteorologist studies what are called hydrometeors. That's where the name meteorologist comes from. We're not called weatherologists. A meteorologist studies hydrometeors. Now, you may be wondering, what in the world is a hydrometeor? I've never heard that word. Well, there are 4 major types of hydrometeors: rain, sleet, snow, hail. Those are the 4 major types of hydrometeors. In other words, a hydrometeor is precipitation. A meteorologist is a scientist who studies precipitation. Where is it raining? When's the next snowstorm going to hit my town? Is that thunderstorm coming later this afternoon? These are questions that meteorologists have to answer because they all involve precipitation. And so that's where that name comes from. So, as a meteorologist, I need to make sure I keep on top of precipitation. All right. Before we get into this, a quick question. Joey Chang, can you tell us about Virga? And that's from Zara. Great question. Virga is precipitation that is falling from the clouds, but never quite makes it to the ground. Virga is rain or snow that falls through dry air in our atmosphere. And the dry air helps that precipitation to evaporate before reaching the ground, where we possibly feel it. A lot of times, if you look at a cloud and you can see these little streaks that come out underneath the cloud, that's precipitation. But if those streaks disappear in the middle of the air, that's probably because that moisture, that precipitation, is falling into dry air, not getting you wet on the ground. And so that's called Virga. That's a very good question. Way to go, Joey and Zara. Okay, let's get into some of the meat of what we're talking about today. So the first type of precipitation is one that everybody knows all about: rain. And we're getting rain today. So boy, isn't this good timing? Now, did you know that very often rain doesn't always start out as rain? In fact, very often, did you know that rain starts as snow? In fact, today, even though near the ground, temperatures will be in the 40s and 50s. If you could fly up into the sky, say about, for sure, 8,000 to 10,000 feet up in the sky, the temperatures are below freezing. And so as precipitation falls through that column of the air, it's actually coming down as snow. But then the snow melts and turns into rain in a deeper layer of warm air that extends from the ground, the Earth's surface, and up into the atmosphere. So it starts as snow, and then as it hits that warmer layer of air, that precipitation begins to melt, and it turns into rain drops and comes all the way down and gets us wet on the Earth's surface. Now, before we go any farther, I probably should back up a step and talk about, why does precipitation even happen in the first place? You know, a lot of times what happens is up in the clouds where it's cold and temperatures are below freezing, you know, we're getting these supercooled water droplets that are flying around inside the clouds. Now, these water droplets are very tiny and light and fine, and they don't really fall to Earth all by themselves. But what happens is they often stick to pieces of dust or dirt or even volcanic ash or salt, things that are floating around inside the cloud. Those little bits of debris that are microscopic, they're so tiny, they're called condensation nuclei. And condensation nuclei is floating all around us all of the time. It's so small we really don't even see it. But as this condensation nuclei flies through the cloud, the supercool water droplets stick to little bits of sand and salt and dirt and debris, and that helps that create like little beads of water, little water droplets. And of course, if it's cold enough, you can start to develop snowflakes as well. So it all starts from what is called condensation nuclei. That helps the moisture to stick to something, and eventually, as it gets heavy enough, it does fall down towards the ground. All right, so that is rain, the first of a few different types of precipitation. Now, what exactly is freezing rain? Well, it pretty much starts off the same way. We have snow falling out of the clouds, and then that snow melts into rain as it falls through a very thick layer of warm air above the surface, but right near the ground. That's where temperatures all of a sudden fall below freezing again. So we have snow melting into rain, and rain's coming down, but right before it hits the ground, temperatures fall below 32 degrees Fahrenheit. And that is such a shallow layer of cold air near the ground that rain doesn't have a chance to freeze up until it hits something, whether it be the ground or maybe tree branches or power lines, and all of a sudden that water from the rain flash freezes to whatever cold surface it's sticking to. And sometimes during the wintertime, if we get an ice storm, you'll tend to see the tree branches get weighed down by the ice. The water hits the tree branches, it turns to ice, it flash freezes, and that ice is rather heavy, and it pulls down on the tree branches, or it pulls down on the power lines, and if that weight of the ice on power lines pulls down hard enough, all of a sudden we lose power. But it's all because of that very shallow layer of sub-freezing air that's just barely hovering above the ground. If it wasn't for that very shallow layer of really icy air near the ground, it would be just rain, but it's that very shallow layer of air just above the Earth's surface that causes that rain to freeze once it hits a surface. All right, do we have any questions here? From Rebecca. Hope I'm saying Kuchenbecker correctly. Does it rain in the Arctic or Antarctic? It can. It doesn't rain as often there, though, because of the polar temperatures. You tend to see more snow in Arctic areas, but you can get rain in some Arctic areas. Alaska, for example, gets rain during the warmer months. Sometimes Alaska gets some mild weather during the warmer months where temperatures can get up into the 50s and even some 60s, and they do get some rain. But rain is less common in Arctic areas, and snow is more common. All right, let's see here. Any other questions right now here? Megan Christensen wants to know, how does snow form? Well, we are going to get to that in just a heartbeat. But first, before we talk about how snow gets started, let's talk about sleet. That's another type of precipitation, another hydrometeor that meteorologists are interested in. So, we're looking at the atmosphere in 3 dimensions again. This time it's a different kind of sandwich, right? So we've got up in the clouds, freezing air, snowflakes, and they fall into a layer of milder air or warmer air where the temperatures are above freezing. So the snow melts in a warm layer of air above the surface, but then it falls into a deeper layer of sub-freezing air, colder air where the temperatures are around and below 32 degrees. Now notice that layer of freezing air near the ground is a little thicker compared to the shallow layer that we had when we had freezing rain. So that rain refreezes in time before it hits the ground into ice pellets, because that's what sleet is. Sleet is little ice pellets. Like if you are at home and sometimes it's sleeting, you can hear the sleet, like little ice pellets that may be bouncing off your window or perhaps off the driveway, or if you're in the car with mom and dad, the sleet ping, 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 pings off of the windows and the windshield. And so it's that rain that manages to fall into a thicker layer of cold air just above the Earth's surface, above the ground. So you can see how it starts off as snow and turns to rain and then turns into ice pellets before hitting the ground. Now, because that rain was able to turn into ice pellets before hitting the ground, you see the little tiny pieces of ice bouncing around on the ground. So that's the big difference between freezing rain and sleet. It's that layer of freezing air that's right near the ground, whether it be a really thin layer with freezing rain or a very thick layer compared to what we get when we get sleet. Okay. Kelly Haro, can water turn into snow right before it hits the ground? Not usually. Usually the snow is formed up in the clouds where we have the right kind of situation and the right conditions where we tend to get what are called dendrites. They're kind of like snowflakes, and they tend to help form a typical snowflake shape. That tends to happen up in the cloud as opposed to down near the ground where the moisture source is not quite as plentiful compared to up in the clouds. And the temperatures are not quite cold enough necessarily as well. So good question though. All right. From Kelly Ludwig Moons, Kayla asked, does it freeze in the mountains? Yes, you can definitely get cold, frozen precipitation in the mountains. In fact, very often in higher elevations, snow and sleet and frozen precipitation is more likely because there's more cold air available. So absolutely. And I want to give a quick shout out. I see here in the comments from Paul Critch, and says here, good morning, Steve. Love listening to you. It says here, Mom, Peter Critch. Okay, so the Critch family, those are my mother and father-in-law. They're from Tennessee, and so they must be catching some of weather school this morning. So, all right. Thanks for watching. All right, so let's switch over. Okay, so we were asked, how does snow happen? So when we get snow, there is no column of warmer air above the ground where temperatures are above freezing. We just have a cold column of air from the cloud all the way down to the ground. So the precipitation starts at snow, and it comes down and ends as snow. So snow remains snow. It doesn't change over due to that freezing layer extending from the cloud base all the way down to the ground. So that's actually really the easiest type of precipitation to know, because there is no changing from snow to rain, or snow to rain to freezing rain, or snow to rain to sleet. Snow starts at snow and ends at snow. It's probably the easiest way to follow that precipitation from the cloud all the way down to the ground. Let's see here. Let's see. We've got another question here from Kevin Scott. Why does the sun shine when it rains sometimes? Well, you know what? That happens a lot in Florida. Sometimes it happens here as well. Sometimes we have precipitation that happens in very narrow columns. So, for example, say we have a shower that's producing some rain, and this column of rain is very narrow. Well, just off to the side of the cloud and the rain shower, the cloud may not be wide enough to block out the sun. So you might go from a sudden rain shower to perhaps some sunshine, maybe just a few hundred yards away, and that's why sometimes you do get sun and rain or precipitation happening at the same time. It's usually in those situations where we often can find a rainbow as the sun's light passes through the precipitation that's falling, which helps to bend the different colors of the spectrum, the different wavelengths of light. And we tend to see reds and oranges and yellows and greens and indigos and blues. So it depends really as far as how narrow that column of precipitation is and whether there's enough cloud cover around that precipitation to block out the sun or not. Usually when we have thunderstorm activity, like especially happening in Florida, you tend to find clouds that are more directly up in the sky, what we call vertical, as opposed to horizontal near the ground. And so you're more likely to find what are called sun showers, like down in Florida. But they can happen in Wisconsin here too. They're more common probably during warmer months as opposed to colder months. Okay. So let's switch over here. Now, something else that we need to discuss. So, well, you know what? Before we do that, I'm going to get out of the way so you can get a better view of this. So I wanted to go side by side with the different types of precipitation. So you can see the different columns of air and how they stack up with warm air and cold air and how that affects the precipitation type. You see that column of air, the thicker it is, the more likely that you're going to get rain. The less likely you have any mild air in there, the more likely you're going to get snow. So it all depends on that column of air. And a lot of times it's hard for us to kind of think of that column of air because very often we're just experiencing what happens on the ground. But we have to look at the atmosphere in 3 dimensions to be able to fully understand how the precipitation is forming and how it's falling and how it actually lands and sticks to the ground. All right, so we measure precipitation with a rain gauge. Maybe your parents have one if they've got a weather station in their yard. And it's very easy to measure precipitation. If it's rain, it's in your rain gauge. There's probably a ruler inside this plastic cylinder, and you can kind of see how much rain has fallen. But did you know that rain doesn't necessarily equal the same amount of snow? Like, for example, if we have 1 inch of rain, that does not equal 1 inch of snow. Like in this example I'm showing you here. Say we get some precipitation. And let's say in this make-believe example here, say that we get 32 hundredths of an inch of rain in the rain gauge. Well, chances are we're not going to have quite the same number as far as snow. In fact, very often, if we have temperatures that are closer to the freezing mark, like 32 degrees Fahrenheit or maybe even a little bit colder, we go by what's called a snow ratio. You see, when snow falls, it tends to be more fluffy. The snowflakes, they tend to expand. They don't stick quite together the same way that water comes together. And because the snow fluffs up when it hits the ground and accumulates, that amount of snow actually fluffs up to a higher total. So in this example here, where the temperatures are near freezing, if we use a snow ratio of 10 to 1, so 32 hundredths of an inch of rain equals 3.2 inches of snow. Now, the tricky thing is that not all the time we get snow, not all the snow events have a snow ratio of 10 to 1. We tend to use a 10 to 1 snow ratio versus rain if temperatures are near the freezing mark. But as it gets colder in our atmosphere, like we get in Wisconsin, we get into some Arctic air masses, we as meteorologists might use a 15 to 1 snow ratio or a 20 to 1 snow ratio. The colder the temperatures are, the more of an extreme ratio we're going to use. Like, for example, I'll use a 10 to 1 snow ratio when I'm forecasting snow when the temperatures are near the freezing mark. But if we have temperatures that are near, so let's say they're in the teens, then I might use a 20 to 1 snow ratio. And because we use a snow ratio, because the snow tends to fluff up as it hits the ground and accumulates, that really magnifies our forecasting mistakes. Like, for example, if we are forecasting rain like we are today, and let's say I miss by a quarter of an inch, well, if it snows, that might mean that I missed my forecast by about 2 or 3 inches. Now that's a big deal for a lot of people, right? So very often if we make mistakes in the forecast, because we're magnifying the ratio change, the mistake is actually magnified. It's a lot easier to see that mistake during the snowy time of the year as opposed to rainy times of the year. All right, so in this example here, we are looking out somebody's backyard in the patio, and temperatures are near freezing. And let's say that we picked up 1/100th of an inch of moisture. This would normally come down as rain, but in this situation, it's melted snow. Well, if we're using a 10 to 1 snow ratio with temperatures near the freezing mark, that 0.1 of rain or melted snow actually translates into 1 inch of snowfall because of the 10 to 1 ratio. So what you do is you take 0.1 and you multiply it by 10. So we're using math here, right? And that gives you 1 inch of snowfall. Now, let me ask you guys a question. What if we have temperatures that are also near freezing, but instead of getting 0.1 inches of melted snow or rain, what if we had 0.5 inches? So half an inch of rain or melted snow. How many inches of snow would that be? Not 0.1, but what if we had 0.5? So you would take the 0.5, times it by 10 in the snow ratio, and the answer is 5 inches of snow. That's right. Because remember, 1 inch of rain does not equal 1 inch of snow. If we use a 10 to 1 ratio, 1 inch of rain would actually equal 10 inches of snow. But sometimes we are unable to use that 10 to 1 ratio because it's colder. And when we have colder weather like Arctic air, what happens is the snow doesn't quite stick together as nicely. See, when we have packing snow and temperatures are near freezing, the snow is very wet, it sticks together, but when temperatures are colder, like in the teens, the snow is more dry and fluffy, and the snowflakes don't stick together very well. So when they hit the ground, they really fluff up. So that really changes the amount of accumulation that we actually get. So in those kind of situations, we might use a different snow ratio, like for example, a 20 to 1 snow ratio. So in this pretend situation, if we get 1/10 of an inch of rain or melted snow, and it's cold, temperatures are in the teens, and if we use a 20 to 1 snow ratio, that actually means not an inch of snow, but 2 inches of snow because we're using a 20-to-1 ratio as opposed to a 10-to-1 ratio. See how that snow ratio makes a big difference on how much snow we actually get? That's why sometimes those snow forecasts that we come up with don't always pan out. So, what would you say if we had a 20-to-1 snow ratio, but instead of getting 1/10 of an inch of moisture, what if we got half an inch of moisture, 0.5? How much snow would that be? Anybody know the answer to that? Well, you would take the 0.5 and times it by 20, and the answer would be 10 inches of snow. Now, whoa, now we're talking about a whopper of a storm, right? 10 inches of snow. So the more liquid equivalent, the more moisture, and often the more extreme snow ratio yield those higher snowfall totals. That's a lot of math, but it makes a big difference on how much snow we get, and it also helps to magnify our mistakes because, you know what, as weather forecasters, as meteorologists, we're not perfect and we do have flaws and make mistakes, and snow forecasts definitely help to magnify those mistakes. Okay, any questions? I know that was a little bit on the heavy side, especially with the math there. Let's see here. Let's see here from Lisa Allen Carney. Macy and Caleb would like to know why sometimes there are really big raindrops or really big snowflakes. You know what? Raindrops and snowflakes can get big, especially if they're sticking together. Like, for example, we tend to get big snowflakes when the temperatures are around or even a little bit above freezing near the ground, because as the snow falls, the wet snowflakes, because they're wet, they tend to stick together and create larger snowflakes. You tend not to see snowflakes sticking together when the snow is dry and powdery, and if anything, the snow looks like almost little grains that fall down from the sky. But when the snow is wet and sticky, you tend to get these big, fat flakes that come on down. Poof, there I am, magic. So that is often what happens as far as how we get those big, fat snowflakes. All right, let's move on here. So now I know you kids don't drive, but I know your parents do. And this also helps to illustrate the different types of precipitation and how people behind the steering wheel when they're driving, how they need to make sure that they're driving carefully in different types of precipitation. You know, this is the main reason why you guys, other than a pandemic, don't have school during the winter time, because we are getting icy roads or snow-packed roads. They can be dangerous to drive on. We don't want other people getting into car accidents and people getting hurt. Or perhaps in rural areas, the school buses can't get through the roads that can't get plowed, especially in those rural areas. And so road conditions impact adults and they impact kids too. All right, so when it's rainy and the roads are wet, hopefully drivers turn their headlights on. They don't use the cruise control where they're kind of using the same consistent speed. They make sure that they should slow down and avoid hydroplaning. Now, hydroplaning can be a very dangerous situation. That is when you're driving and the car's tires go around and round and round and they grip the pavement, but when you hydroplane, the tire loses contact of the pavement because of a layer of water underneath the rubber of the tire. And so the tire is not able to grab that road, and all of a sudden the car begins to slide because of that layer of water in between the tire and the pavement. And in those situations, drivers should never slam down on the brakes if they're hydroplaning, because then they can lose control of their car. And regardless, you want to make sure you keep a safe distance between you and the car ahead of you if it is raining, because sometimes it takes longer to slow down. So when we have freezing rain, I would argue when there's freezing rain, that is the most dangerous weather conditions to drive in. It gets very, very icy. The tires have a very hard time gripping the road. Drivers have to reduce their speed. If they even have to drive at all, it's probably best they don't and they can just stay home until the ice storm is over. Avoid sudden stops. And if people are on the ice and they're sliding, it's best they turn the wheel in the same direction as the slide and avoid hills and steep inclines, because sometimes you just don't have enough momentum to get up over that hill when the tires can't grip that icy road. All right, so That's what happens when you have freezing rain. Now, here's sleet. You see the little bits of sleet bouncing on the pavement there? Pretty cool, huh? So road conditions in these situations are icy. Sometimes they're slushy. Drivers need to slow down, and if they can not drive at all, that's great. Avoid sudden stops. If they're sliding, turn the wheel in the direction that you're sliding in. Avoid hills and steep inclines. Very similar to freezing rain, except in sleet, you might have a little better traction compared to freezing rain. And in snow, in probably the most common winter driving conditions in Wisconsin, when it's colder, you gotta be careful. Accelerate and decelerate slowly. Never do any herky-jerky moves when you're driving in the snow. You slow down, reduce your speed, avoid locking up the brakes and jamming down on them. Don't go so fast and power up hills because that's often a recipe for sliding off the road. And don't stop when going up a hill. Just try to keep a slow, consistent speed when you're going up that hill and maintain that forward momentum, but slow enough where if you need to brake gently, then you can. All right. Now, a few weeks back, we talked about thunderstorms, and I want to go back and talk about hail one more time because it is a type of precipitation. Before you do, let me see if we have any other questions here. From Tiffany Murdoch, 6-year-old Ruin wants to know how many feet of snow can come from one storm. Great question. You know, we tend to see some good snowstorms here in Wisconsin, but sometimes we get lake effect snow where you tend to get the wind blowing across, like a cold wind coming across the Great Lakes, and that warmer air that flows over the colder water. Or actually, no, other way around. I'm sorry. Colder air coming over the warmer water, I got flip-flop there, that creates these bands of snow that happen on the east side of the Great Lakes. And you can get heavy bands of snow where the snow is piling up in feet of snow. In fact, there are some areas of the Great Lakes that will get over 100 or more inches of snow every season. Now, that doesn't all come down at one time, but there have been some storms, especially on the east side of the Great Lakes, where you're getting 2, 3, 4 feet of snow at a time. I remember when I was a very young meteorologist, I used to do weather in Erie, Pennsylvania, and I had to fill in for the chief meteorologist out there. And I remember a couple of days before Christmas, I had to forecast a storm that was going to give us 2 feet of snow in about 24 hours. So yeah, you can get some real doozy of a storms on the eastern side of the Great Lakes. We can get big snow here in Wisconsin, but in lower Michigan, especially on the east side of Lake Erie, the east side of Lake Ontario, in an area called Tug Hill in New York State, often gets some of the most snow across the Great Lakes. All right, so let's see here. What is the highest snow ratio you've ever used? From Jake. That's a good question. I've used snow ratios anywhere from 5 to 1 to, I think, 25 or 30 to 1. But those snow ratios around 25 or 30 to 1, those are situations where it is very, very cold. You probably are dealing with temperatures that are around and even below 0. All right, so let's talk about hail real quickly here. So hail happens in thunderstorms, and what happens is you need a lot of rapid rising air to go up into the thunderstorm, the cumulonimbus cloud. Thunderstorms are very tall. They can be 6 to 10 miles high. In tropical areas, they can be 12 miles high, but way up in the thunderstorm, it's below freezing. And so what happens is that, remember we talked about condensation nuclei, little bits of salt and sand and dirt flying around in the cloud. If we get water droplets that stick to these condensation nuclei that are floating around, we get these little beads of moisture that float around. And then what happens is as they go up into the thunderstorm where it's really cold, then they freeze up into little bits of ice. So raindrops are carried up into cold parts of the atmosphere and they freeze into little tiny hailstones. Now those hailstones are up in the thunderstorm cloud because of the rising warm air, what we call an updraft. But there's also columns of air that's coming down the thunderstorm, what we call a downdraft. And so what happens is those little bits of ice get caught up in a downdraft and they tend to sink, where more rain droplets will stick to that piece of ice and go back up in the updraft and freeze and make that little bit of hail a little bit bigger. Then the hail goes down, more water droplets stick to the piece of ice, it goes back up into the updraft and freezes and makes an even bigger hailstone. So hail is carried up and down inside a storm cloud. Hailstones, they grow by colliding with supercooled water droplets inside the cloud. So those supercooled water droplets hit the hail, stick to the hail goes up, and those water droplets freeze and make the hailstones bigger and bigger and bigger. And this continues up and down inside the thunderstorm until the hail gets too big. It gets so heavy that the rising column of air, the updraft, is not strong enough to keep it aloft. And so that hailstone comes crashing back down to earth, and we see the hail that we do see. So the process that creates that hail, where the supercooled water droplets stick to that ice and make it bigger and bigger and bigger, is something called accretion. Accretion is basically where you're having a piece of ice, supercooled water droplets that stick to that ice to help make that ice bigger and bigger and bigger. So the accretion, that process, and the up and down motion inside the thunderstorm helps to grow that hail bigger and bigger and bigger until it's so heavy that the winds can't keep that heavy hailstone up and it comes down and crashes to the ground. Hopefully that makes sense. All right, so any other questions here? From Sarah Catherine. Hi, Sarah Catherine. How do clouds form? From Laura. So clouds form because of condensation. So if I take my glasses and if I go like this, and you can see the fog on my glasses, what's happening is that water vapor coming out of my mouth, spit, sticks to the glasses. Now the glasses are a lot cooler in temperature than what's inside my mouth. So that water vapor comes out and it hits the glasses. The water vapor is forced to cool down very quickly until we hit what's called our saturation point, our dew point. And that helps to create that layer of fog on the lenses. That's condensation. So when we have moisture in the air, water vapor, sometimes humidity, that rises up in the sky. And up in the sky, it gets colder. As that water vapor rises into the colder atmosphere, that water vapor cools down. And once it cools down, as cold as it can go, and hits its saturation point, what we call the dew point, we create condensation. Clouds, if it's near the ground, fog. That's exactly how cloud cover is created. It's the rising air that tends to cool down and become completely saturated to create water vapor. The water vapor basically gets squeezed out of the air to form the clouds, the condensation, which is part of our water cycle. All right. Let's see here. One more question and then we'll move on here. From Jane Ryan. Can there be rainbows when it's snowing yet the sun is out? Yes, you can have rainbows as long as there's precipitation and sunlight to shine through the precipitation. And it doesn't matter if the precipitation is rain or snow, so you can have a rainbow that is happening through snow. That is possible, yes. All right, so we saw how hail happens. Now, there is one other type of precipitation that we did not talk about, and we got some recently, and it's called graupel. Now, if you're familiar with graupel looks like, you've ever gone and gotten Dippin' Dots ice cream? Dippin' Dots are delicious. You get like the little bowl and the little ice cream pellets, and then you got the little plastic spoon, and you're eating Dippin' Dots. Graupel happens in a very similar way to hail, but hail comes from thunderstorms, and graupel does not. Graupel comes from clouds that are more horizontal as opposed to vertical, we call stratus clouds. But they both form from what we call accretion. Accretion in a hailstone has a piece of ice and supercooled water droplets that stick to it. But with graupel, the core of the grapple is actually a snowflake, so not a piece of ice. So we have a snowflake and supercool water droplets that stick to that snowflake. And that snowflake and that we call ice that forms around it tends to grow and grow and grow. Now, when grapple falls, it looks like hail, but if you pick up grapple, it doesn't feel like hail. It's actually very soft, and you can kind of squish it in your fingers. Like, again, like Dippin' Dots ice cream. It looks similar, but it's not. And also, grapple tends to be white as opposed to clear because it's not ice. It's actually a snow pellet. Grapple is a snow pellet, and it comes down on the ground, and it collects, and it looks like hail, but it is not. So that is a form of precipitation called grapple. Okay. Let's see here. Dave Newman. Anna wants to know how you learned all of your meteorologist knowledge. Well, the most important thing is for you, if you want to know about meteorology, is to do well in school, do well in math, work hard in math, work hard in science. If you have computer classes, do well in those. And then I went to college. I went to Valparaiso University. I graduated there with a degree in broadcast meteorology. I spent 4 years there studying, and I applied that to my job that I'm having right now. So going off to college and studying meteorology, that's how one becomes a meteorologist. Most TV meteorologists will spend 4 years in college. A lot of meteorologists who are not working in broadcast, who are working in other places like maybe the government or airlines or consulting firms or whatever, the military too, they probably spend more years in school, maybe 6 to 8 years, and perhaps even go on to get their master's or their PhD degree. All right, so any other quick questions? If not, we will wrap this up. And gosh, do I have to give you guys some homework? Because I usually give the parents homework, right? Yes, I should probably give the parents some homework, and you kids can make sure that the parents are doing the homework. And actually, kids, you can help out your parents with the homework. So we talked about the snow ratio, how 1 inch of rain does not equal 1 inch of snow. Sometimes 1 inch of rain equals 10 inches of snow, or if the ratio is 20 to 1, then sometimes 1 inch of rain equals 20 inches of snow. But let's give the parents and the kids something to do together over the next few days. So it's going to rain today, and it's going to rain at times Tuesday and Wednesday, and perhaps into Thursday morning. Here's what I want you to do. I want you guys to watch our 24/7 weather channel on Spectrum. That's channel 992. Or if you're getting our 24/7 weather channel over the antenna, that's 2-2. And at the end of the day, I want you to watch, and I want you to see how much rain we get each day. So let's say that today we get 1/4 inch of rain. Okay, then I want you to write that down in a log. And then with your son or daughter, I want you to, okay, figure out if we got this much rain today, how much snow would that be if it was wintertime? And if we did have a 10-to-1 ratio, or if we had a 15-to-1 ratio, or a 20-to-1 ratio. Now, obviously, this involves some math. So this is where moms and dads are going to hopefully help out their kids and try to help them figure out that, okay, if we got this rain today on April 27th, but if it really came down to snow, how much snow would we have to shovel today? So try to figure that out over the next couple days. Today, Tuesday, Wednesday, Thursday, as we get different rounds of rain across northeast Wisconsin. And again, you can see the rainfall totals at the end of the day by watching our 24/7 weather channel. All right. Hey, thanks for joining me in weather school. I hope you guys had a fun time talking about types of precipitation. Before I go, I've been asked, am I going to keep doing this? I will try to keep doing this through the rest of the school year if I can come up with enough content, because it takes a while to generate some of the graphics and some of the, the fancy scenes that you're seeing. I will try to do this the rest of the school year and probably up to the first Monday in June, because I know you kids are stuck at home, while the COVID-19 pandemic is going on, and I want to try to be there for you for the rest of the school year. So I will try to come up with some more things to talk about in regards to our weather and hopefully give you guys a little bit of atmospheric education. And who knows, maybe there's a few of you out there that someday will grow up and become meteorologists. If even just one child out there grew this interest in science, then I would feel like this was all well worth our time. All right, you guys take care. Stay dry with the rain, and I hopefully will catch you guys next Monday. All right, bye guys. Have a great day. See ya.